Inshallah, in today's class, we are going to discuss about the orthogonal trajectory questions. See, a curve which cuts every member of a given family of curves at that is perpendicular 90 degrees. Then the curves are called orthogonal trajectory of the given family of curves. See method how to find. See here, the given curve will be like this. Suppose this is f of x comma y comma c. This c is called the parameter. C is called the constant way changing constant. C is the parameter. We have to differentiate and eliminate the c from here. Differentiate and eliminate c. Take out the c from here. Remove the c from here. So suppose we get the equation f of x comma y comma dy by dx. Now, how to solve for orthogonal trajectory? We have to change dy by dx by minus 1 by dy by dx. This is the main method. To solve, to get the orthogonal trajectory curves, we have to replace dy by dx by minus 1 by dy by dx. Sometimes we can write short, okay, sometimes questions will be very bigger. So we can write like this also. Dy by dx means y1. So we can replace y1 by minus 1 by y1. Minus 1 by y1. After replacing y1 by minus 1 by y1, we'll get the equation in terms of minus 1 by y1. Now you have to solve this from the any of the previous methods. Any of the previous methods, if we solve, we'll get the curves which are orthogonal to the given curves. One more thing, very important concept. This is what is self-orthogonal. Suppose we are changing y1 to minus 1 by y1 or dy by dx to minus 1 by dy. Before changing, what is the equation? If after changing also the equation is same, the equation is same, then we say self-orthogonal. The curve is self-orthogonal. If the curve remains same, do not change, unalter, before and after replacing y1 to minus 1 by y1. Before replacing whatever the equation is there, after replacing y1 to minus 1 by y1 also, if we get the same equation, then we say that the curve is self-orthogonal. The curve is self-orthogonal. So you just revise this, you write on a paper the method, okay, revise it. Let me do the questions on this orthogonal trajectory. Now see here one question. Prove that the coaxial system of parabolas y square equals to 4a into x plus a is self-orthogonal. What is given here? Y square equals to 4a into x plus a. Let me denote this as 1. Now actually we have to differentiate and take out a from this. First we have to differentiate and take out a from this. So let me differentiate with respect to x. Differentiation with respect to x. Y squared, the dy dx of y squared is 2y. If we differentiate y, we write dy by dx equals to 4a into d by dx of x is 1, d by dx of constant is 0, so into 1 suppose. So bring this 4 here, therefore we get a equals to 2y by 4 dy by dx. 1s are 2s are. So we got the value of a, therefore a equals to y by 2 dy by dx. Now let me substitute this a in the given equation. So y square equals to 4 into a. The value of a is y by 2 dy by dx into x plus a. A is y by 2 dy by dx. See here, I am substituting the value of a in the given. Y squared equals to 4 into a. The value of a we got y by 2 dy by dx into x plus c. Now let me change this. If we get cancellations, you see here, 2 1s are 2 2s are, and this y and square will get cancelled. What is left here? Y equals to 2 into dy by dx into x plus y by 2 dy by dx. Okay, so we left with y equals to 2 into dy by dx into x plus y by 2 dy. Let I am noting this as equation 2. Now what we have to show? Self-orthogonal. So for self-orthogonal, we will change dy by dx by minus 1 by dy by dx. After changing also, if we get the equation same like this, then we can say that the curve is orthogonal. For orthogonal trajectory, what we have to do? We have to change dy by dx by minus 1 by dy by dx. Okay, so let me change this one. In place of dy by dx, I am substituting minus 1 by dy by dx. So this will become y equals to 2 into minus 1 by dy by dx into x plus y by 2 into, in place of this we have to write minus 1 by dy by dx. So what we did, for orthogonal trajectory we have to write dy by dx by minus 1 by dy by dx. So I'm changing this. Here also I'm changing this. Now let me solve this one step by step. You see here, bring this here, bring this here. So this will become y into dy by dx equals to plus into minus minus 2 into, what is left here, x plus into minus 1 minus y by plus into minus y by 2 into dy by dx. So let me do one thing. I'm doing, if I'm bringing this 2 here, it will be y by 2. We have to change like this, no? So I'm bringing 2 here and multiply this with minus. If we bring 2 here, it will be y by 2 dy by dx. Now if you multiply with minus, this will minus into plus will become minus x. Minus into minus will become plus y divided by 2 into dy by dx. Now see here, if we bring minus x here, it will be plus x. I'm writing here. You see here, y by 2 dy by dx minus x on the other side, it will be plus x equals to y divided by 2 into dy by dx. 2 into dy by dx. Next step, bring this here. So what is left here? Therefore y equals to, I'm bringing this here, 2 into dy by dx in bracket. Let me write like this. I'm writing first x plus y by 2 dy by dx. Let me note this as equation 3. Now see here, we get the same equation as 2. What is 2 here? See here, 2 is y equals to 2 into dy by dx into x plus y by 2 dy by dx. The same equation, after changing also we are getting the same equation. Y equals to 2 into dy by dx into x plus y by 2. So from 2 and 3, what is the, we can say that the result is, after changing also we are getting dy by dx, same equation. Therefore from 2 and 3, the given curve is self-orthogonal. You write this. The given curve is self-orthogonal. The given curve is self-orthogonal. The given curve is self-orthogonal. Now see the next question. Prove that the family of confocal conics are self-orthogonal. Because the question is so lengthy, just I am using, instead of dy by dx, I am using the symbol y1. Instead of dy by dx symbol, I am using the symbol y1. So let me differentiate, and here lambda is the parameter. That means we have to differentiate and find the value of lambda, and then we have to substitute in this. So first let me differentiate and find the value of lambda. Let me differentiate. X square is 2x divided by a square plus lambda plus y square is 2y. Differentiation of y is dy by dx, that is y1. We are denoting with y1 by b square plus lambda equals to, constant is 0. You do one thing, let me bring one to other side. I'm bringing this on the other side. What is left here? 2x by a square plus lambda equals to minus 2y y1 divided by b square plus lambda. Now you do one thing, 2 will get cancelled. Now let me cross multiply this one. See here, if we cross multiply, x into b square x plus x into lambda x lambda equals to minus into plus minus a square y y1 minus a square y1 minus into plus minus lambda y. What we did here, we cross multiply b square plus lambda with x and this with minus y1. Now we have to find lambda, so bring lambda up to one side and other numbers to other side. See, one is here x lambda, bring this minus on the other side, it will be plus lambda y1 equals to, bring this here, it is minus a square y1 minus b square x. Now let we take minus common here, and next thing is you take common from here lambda. If we take lambda common, what is left here, x plus y1 equals to, if you take minus common here, it will become plus a square y1 plus b square x. Now you are multiplying here, if you bring here it will be divided, therefore we will get the value of lambda equals to minus of a square y1 plus b square x divided by x plus y. Now let me denote this to, let me no, otherwise let me do one thing. Now substitute lambda in 1. Now let me substitute the value of lambda in the question. What is question we are having? See here, we are having the question x square by a plus a square plus lambda, we will substitute this one, b square plus lambda, we will substitute this one. Okay, so therefore substituting in one, x square divided by a square plus lambda, the value of lambda is minus of a square y1 plus b square x divided by x plus y1 plus y square by b square plus lambda, the value of lambda is minus of a square y1 plus b square x divided by x plus y1 equals to 1. Now let me solve little. Let me do one thing. If we take LCM, we get multiplied with this and this will come in the numerator. If we take LCM, this will get multiplied with a square into x and this will come in the numerator like this. You see here, x square into x plus y1 divided by, now multiply this with a square into x, a square x plus a square into y1, a square y1 minus into plus minus a square y1 minus into plus minus b square x. In the same way, you see here, if we multiply this, if we take LCM, this will get multiplied with b square and this will get in the numerator. So y square into x plus y1 divided by, now multiply b square into x, b square x plus b square into y1, b square y1 minus into plus minus a square y1 minus into plus minus b square x equals to 1. So let me solve, continue this one. See here, we'll get cancelled this one. A square y1 minus a square y1 cancel. From this 2, if we take x common, it is left with a square minus b square. X square into x plus y1 divided by, if you take common x, what is left here, we left with a square minus b square. In the same way, see here, minus b square x plus b square x cancel. Let me take common from this 2. See here, y square into x plus y1. What we are going to take, let me take minus common here. If we take minus common, this 2 will become same, minus y1 I am taking common. If you take minus y1 common, this will become plus a square and this will become minus b square. Why we have taken minus common? Now this 2 will be same, a square minus b square, a minus square minus b square. We can take common in the next step. Therefore we have taken minus common equals to 1. Now you x square x will get cancelled and y square will get cancelled, plus into minus will become minus. Let me take common from both. You see here, x plus y1 here also, x plus xy1 here also. Let me take x plus y1 and the denominator we can take common, a square minus b square. We have taken common from both. Okay, so what is left here? Here it is left with only x. Now plus into minus minus, plus into minus minus, what is left here? Y by y1, y by y1 equals to 1. Let me denote this as 2. Let me denote this as 2. Now what we have to prove? We have to prove self orthogonal. For self orthogonal we have to replace y1 by minus 1 by y1. For orthogonal trajectory, what we have to do? We have to replace y1 by minus 1 by y1. Let me do from the starting of the board. After changing y1 by minus 1 by y1, if we get the same equation like this, then we can say that it is self orthogonal. Now see here, let me substitute in place of y1 minus 1 by y1. See here, x plus y into, in place of y1 minus 1 by y1 divided by a square minus b square into x minus y by, in place of y1 we are writing minus 1 by y1 equals to 1. Now see here, what will happen? This one, x plus into minus minus x minus y by y1 divided by a square minus b square into, minus into minus will be plus, this will become in, this will come in the numerator, x plus y by 1 equals to 1. Now note this as 2, this is 2, sorry, note this as 3. Now see here, we are getting the same equation. Watch carefully. X minus y by y1, x minus y by y1 by a square minus b square, a square minus b square, x plus y by 1, x plus y by 1. So after replacing in place of y1 minus 1 by y1 also, we are getting the same equation before replacement. That means this is self orthogonal. Therefore, from 2 and 3, the given cursors, the given family of curves is self orthogonal. The given family of curves is self orthogonal. Now see the next question. Find the orthogonal trajectory of the family of curves. Now let me differentiate here. Differentiation with respect to x. Differentiation with respect to x. D by dx of x power n will be n into x power n minus 1. Similarly, n into y power n minus 1. When we differentiate dy by dx with respect to y, here constant is 0. Now watch here, after differentiation we already the parameter is eliminated. Here we got 0, so in this equation we don't have any parameter, so we can continue from here. No need of substituting value, finding a, because we don't got here a. So let we continue here itself. This is the equation. No, let we do one thing. We take 2 by 3 common. If we take 2 by 3 common, what is left here? It is left with x power 3 ones are 3, 2 minus 3 minus 1 by 3 plus y power minus 1 by 3 dy by dx equals to 0. Now this constant will go there, it will become 0. Now let me change the equation for orthogonal trajectory. For orthogonal trajectory, what we can write? We can write dy by dx equals to minus 1 by dy by dx. Now let me change this one. So what is left here? X power minus 1 by 3 plus y power minus 1 by 3 into this value is minus 1 by dy by dx equals to 0. Now I'm bringing one value here. Suppose I am bringing here. So plus into minus minus y1 power minus 1 by 3 by dy by dx equals to minus x power minus 1 by 3. So minus minus will get cancelled. Now cross multiply this. This will get here y power minus 1 by 3 equals to x power minus 1 by 3 dy by dx. Now what we have to do? We have to change it. See, this is here. It's a question. Now let me change. Bring this dx here. Bring this here. You see here we can write like this: y power minus 1 by 3 dx equals to x power minus 1 by 3 dy. Now write y with dy. and x with dx. Dx, bring this here, by minus x power minus 1 by 3 equals to dy by, bring this here, y power minus 1 by 3. Now if you bring this in the numerator, the sign minus will become plus. I'm writing here, if we bring this in the numerator, this minus sign will become plus. X power 1 by 3 dx equals to y power 1 by 3 dy. Now this is the first method, variation of variable separation method. With dx we got x, dy we got. Now we can integrate now, integrating both sides, so integration of x power 1 by 3 dx equals to integration y power 1 by 3 dy. Now integration of x power n will be x power n plus 1 by n plus 1 equals to y power n plus 1 by n plus 1 plus c, plus c. Now what will be this one? 3 ones are 3, 3 plus 1, 4 by 3. From the denominator, if you bring up 4 by 3, it will be 3 by 4 x power 4 by 3 equals to 3 by 4 y power 4 by 3 plus c. Now we can live anywhere, we can even cancel this, or I'm doing one thing, bring this here, let me take 3 by 4 common, x power 4 by 3 minus y power 4 by 3 equals to c. Bring this here, x power 4 by 3 minus y power 4 by 3 equals to 4c by 3. This is constant, we can write some another constant, x power 4 by 3 minus y power 4 by 3 equals to, suppose I am writing k, we can leave here itself or here, anywhere we can leave the question. It is finished. You see here, find the orthogonal trajectory of the family of curves. Now let me differentiate and find the value of a, and let me substitute in this. Suppose this is 1. Now differentiating with respect to x, a as it is, y square is 2y. Differentiation of y is dy by dx. X cube is 3x square. X cube is 3x square. Now let me find a from here. So a equals to 3x square divided by 2y dy by dx. Now let me substitute this in 1. We have to eliminate a from here. In the previous question, because after differentiating we got 0, it isn't left with a, so we can directly continue the question. But here a is left here, so we find the a value and let me substitute in 1. So value of a is 3x square by 2y dy by dx. This is a into y square equals to x cube. Now let me continue this one. Let me first cancel the numbers. See here, this y and square will get cancelled. This x square and cube will get cancelled. Now what is left here is 3y, 3y, 3y is left here. Bring this to here, it will be 2x dy by dx. Now in place of dy by dx we can change for orthogonal trajectory. What we write? Dy by dx equals to minus 1 by dy by dx, or we can write like this, minus dx by dy. Now let me change this one, 3y equals to 2x minus dx by dy. Now bring this dy here, it will be 3y dy equals to 2x dx. 3y dy equals to 2x dx. Now we got y variable separate and x variable separate, so no need to change any method. Let me integrate both sides. So this will become, integrating both sides, integration 3b, I am taking out y dy, 2 integration x dx. Now 3 into integration of y will be y square by 2. 2 into integration of x will be x square by 2 plus c. Now see here, we can, you do one thing, this will get cancelled. Now bring this here, x square minus 3y square by 2 plus c on the other side minus c, plus c on the other side minus c. Now last, let me take LCM. 2 into x square will be 2x square minus 3y square equals to minus 2c. If we take LCM, 2 into x square, 2x square minus 3y square equals to minus 2c. Let me change some constant. 2x square minus 3y square. This is constant, we can't write any constant here. So the equation is 2x square, sorry, here we did a little mistake here. Here we are having minus, no, so minus is left here. So minus will be here. This is minus. So you do one thing, if you bring here, it will be plus. Minus on the this side will be c. If we take LCM, this will be 2x square plus 3y square equals to 2c. So we can write 2x square plus 3y square equals to k. 2x square plus 3y square equals to k. We left actually this minus. You write this minus here, again minus here. So this minus of integration of x is x squared by 2. 2 will get cancelled. If you bring this minus x square here, it will be plus x square plus 3y square by 2 equals to c. If you take LCM, 2 into x square, 2x square plus 3y square equals to 2 into c, 2c. This is constant, we can write any number. Inshallah, let we do one more question, was few more questions in the next class based on orthogonal trajectory. And another form of orthogonal trajectory is polar coordinates. How to solve in the given question is in polar coordinates. That we'll see inshallah in the next class. One more question is there, somewhat a little tough, bigger question. That we will inshallah continue in the next class inshallah. So I request you all the students to subscribe this channel, share and link with your friends inshallah. We're going to continue in the next class inshallah.